Hello folks, well today we've got a Midland 77104 UK, the baby Midland. Hello, that fluorescent light wants changing, which is this one. It's the UK version, it's December 1990, not the DUK, which isn't quite as good on receive. This is the one where it has channel 9 printed on it. The DUK doesn't have the channel 9 because it always boots up on channel 9. This uses a traditional channel selector switch and the LC7136 or 7137 Sanya synthesizer, rather than that pesky one that boots up on channel 9. Like everybody wants the radio to come on channel 9. So we've got the factory original mic here, and it's got the plasticky locking-y DIN thing, which is you don't often see. We once had a CPT version of one of these early on in the CPT days, and I don't know where that's gone because I didn't sell it, and it should be here somewhere. Don't see many of those. I've got a scrap one in a box which we bought in a batch of stuff, but that doesn't help us. Right, we want our, without rattling the mics about, right, connect it up to the test equipment. So some of these can suffer from dry joints, but they're not like the 77095 and 77099 that always have dry joints. So let's put the power on. We have a short circuit. As ever, we've only got 20 minutes. Always kind of fit these in between other things. Take the speaker off. So I'm just going to power it up now. We've got no lids on it. It's okay. Oh no, it's not. It's 300 milliamps. It's a short circuit. So we've got a duff protection diode, or has the customer wired it the wrong way round? Oh, there's the protection diode. And that's doing some protecting. I'm going to disconnect it from our crocodile clip leads. We'll get the meter out. I may as well put it on continuity, see if there's a short circuit. Turn the radio on. With the set off, there's no short circuit. Let's go to diode test. I think the easiest thing to do here is to look at another set and just make sure the wires are going in the right place, because the power input is before the on and off switch, obviously, and it's when you switch the power on that the short circuit occurs. Okay, so I found a scrap chassis. Assuming it's scrap, it's sat there with no lids. Oh, yeah, I was told about that switch, yeah. That's by the by. So, I'll have to probably order one of those in. Because one of the things, we don't have that many of these, which is scrap. And I'm not even sure this is scrap till I check this. It's not had anything taken off it, so it could well be a going concern set that just hasn't currently got any lids. So I'm not going to start taking bits off it. It's not actually on the scrap pile, so the kind of time, by the time we get scrap sets, by the time we've bought them in, you know, I've shown you things like this realistic. We bought it like that. You know, so by the time I get them, they have lost most of the bits. But they're still very useful. I mean, like, if this was a scrap set, there's the heatsink, which can be missing in one which has been robbed for parts. So let's see what's happened, what the difference is, if there is one. So I just want to be absolutely sure that these wires go where they do. Yeah, they do. Absolutely right. So I'm not worried about that switch at this stage. We can order one. We might even have one in stock. So let's look at the switch wiring. We've got a brown and a red there, but we've got different colours here. You know what? It's 1988. My I'm going to say stock one, whereas the customer's one's December 1990s. It's 2 years apart, so there can be some differences. So I've got brown and red, and they've got brown and white. Let's see if that white wire. Trouble is, they've got lots of white wires. I think we've got a short circuit probably on the board. So it's a matter of playing spot the difference. It's quite possible it's been gone over for dry joints, and a short circuit's been introduced. Anyway, I'll see what I can find and I'll tell you what the outcome is. Right, well, I can't kind of tell you anything because what I've done is I've gone with the precision ceramic trimming tool, and I've just gone around the regulator legs. I've gone around the audio IC legs, making sure there's a gap. I've gone around the synthesizer leg there, like that. I've gone through the output transistor there, and I've gone through the driver transistor there. I then switched it on, and we've got a display. So I'll go over it with isopropyl later. I think I've twisted that the wrong way round. Okay, so we've got rid of the short circuit. Don't know where it was, but I've told you what I've done. So I'll put SC on initial power up. Right, let's go over to the test set. Let's put this multimeter away because we're never going to need it again on this job, are we? And we'll switch picture in picture on, and it's on the wrong camera, so we want the main meter wherever the mice put it today. Right, press transmit. We're on channel 20 and we've got no transmit. Okay, let's put the signal generator onto frequency. We were on CPT yesterday, so let's put it on 27.79125. And we'll plug in our extension speaker on the wall rather than the test instruments, just in case there's volts coming out. There's nothing coming out, is there? 79125 2779. Okay, we've got 100 microvolt signal on and we've got nothing. Let's put an even bigger signal on. We've got nothing. It's not receiving anything. So we've got no fairy lights. We've got no squelch. And if I go into transmit, we've got absolutely nothing. Well, dry joints in the VCO is the usual thing that comes to mind. I can see it's been gone over for dry joints. However, something might have got missed, so I'll have another look, see if I can see anything. I've had a look at the service notes from the customer, and there's no mention of any dry joints, so there you go. Just goes to show how coming in the post and things can happen. Now, I've got transmit back on this. Have we got picture in picture on? I'll just select camera 1 with the main meter. So we're on channel 20 and we've got some power there. So let's go to the low scale. 1.5 watts. Now I realise that's probably low power, so we'll come back to that. I've got no receive. I had receive for 1 second, and as soon as the soldering cooled down, I lost receive again. So there's a dry joint that I've touched on, but not adequately dealt with. And it's not just a matter of resoldering these; it's unsoldering them, finding the dirty lead, cleaning the corrosion off it. And resoldering it then. So it's not just dab dab dab, it's got to be cleaned. We're going to go over it with isopropyl alcohol. I've had to order a new one, and so we've now got new ones back in stock. So we'll open a fresh one. They're funny, these, you kind of pull up and there's a spout that we use either an RS brush or a toothbrush. It's funny, looking in this is from CPC, that's Combined Precision Components at Preston in Lancashire, and they're a subsidiary of Farnell. And this is, what's this, 1 litre? Yeah, this is 1 litre. And I think these are £15 plus VAT, so your purchase tax is 20% in the UK for trade. And we could buy another make 5 litres for something like £105 plus tax. Well, it's cheaper to buy five of these, and you'd think that the bulk buy would have been cheaper, but there you go. Sometimes it's bonkers. And this has got a seal on it, and I just realised that I just put a screwdriver in there, and I can't get my great big fingers around those. And hopefully, there we go. I will go, because we had that initial short circuit, I'm just going to do some other bits. It's quite quick drying this, you know, it evaporates about a minute. It's just so I can see through the flux, get rid of the flux, and then we can see what we're doing. Okay, where did I put the lid? You couldn't make it up, could you? Same colour as my pliers. So I'll carry on looking for dry joints, and I'll get back to you. Okay, we've got receive. I've done the isopropyl, as you saw, went over for a few more dry joints. We're going to, even if this is what we've done this, when we've done this, it's going to stay on the bench overnight. It'll be rechecked tomorrow to make sure that it still works. It's not good when it's dry joints. It's even more not good when the customer didn't even think there were any dry joints. Right, let's go through what we've got. We'll move our demonstration one to one side. The short circuit on power up was this dodgy switch. I expect I've got to order one of those in. But that keeps it a few more days here. I'll check our stocks of switches, but I don't think we've got any which are, these are sub-miniature. Our radio ham friend Stuart, M0SDM in Grantham, he asked if I'd got any miniature toggle switches about a year ago, and so I had a look what we'd got, and I took out half a dozen to him, and he chose a couple which he paid for, and then the rest came back, and they're still in my porch. So I know where my stock of mini toggle switches are. They're in my porch, but I think we've only got 4, and I don't think we have anything as small as that. Okay, so we're on channel 20. I've manipulated the switch so we've got high power, and what have we got? We've got 3.6 watts. So we'll write that down. I'll move that slightly to one side. Let's go to channel 40, where we've got 3.4 watts. We'll go to channel 1, where we've got 3.5 watts. I think it's 3.6, but it's dropped because it's of the temperature. So we'll manipulate the switch down to low power, go back to channel 20, well, I can't manipulate it, so we're stuck on high power at the moment. Transmit current is set 921 milliamps. Transmitter deviation, I have to reset this from yesterday. Wallow, looks to be about 2.5, but we'll go through to the test set, which I have switched on. And the frequency, let's go through to our camera 2, have a look at the frequency counter if I just move it away from wherever the mice have left it. We've got 2779120, absolutely, well, bang on, 27, I can't even write, 2779120. I'll touch at such a fraction right now, it's neither here nor there. I use the trimming tool, which is wider. So that's the 2mm one, which is the CD20. And these are pence off AliExpress, you know, like 40 pence. And, you know, you buy them from Kyocera and they want £15. And the CD15 is the 1.5mm one we use for most of these. Then we've got these bigger ones, which is like 3mm. And what's this? The YR034D. So these are 3mm, but they do 3mm in that series. So these are ceramic, so they're not. Then we do have the RS one, because you know those. This is a phosphor bronze tool, but you know when you're doing the detector, this is about 4mm or even 5mm, and it fits very well. So there we go. They used to do a little phosphor bronze one, but it's been discontinued, so that's a shame. Right, so we've got it on frequency. So we've actually done one thing. Let's just make sure the signal generator is bang on frequency. It is. So we'll have a look at the synad meter, and we'll go from our extension speaker on the wall to the test equipment speaker. Don't need an earth on this, and it's picking it up through the aerial socket, etc., etc. So we want a much lower signal than what we've got at the moment. I'll tell you what, this is receiving very nicely. They're usually about 0.5. This is 0.42. And then we've got, what, for 10, we've got 0.38. I'll be surprised if we improve on this. And 0.7. Squelch, let's go to full squelch. These are concentric, which can be frustrating. So I've got 100 microvolts on, we're not opening the squelch. Let's show you the attenuator so you can see where I am. So that's 100 microvolts. Here goes the fluorescent again. You know, I ordered from, I've just shown you that isopropyl alcohol. We get these fluorescent lamps from CPC and I forgot to order. Thing is, I've been self-employed and in business since I was 16. So all these kind of things, I've never been and bought them in a shop. And occasionally, you know, you think, oh, I wonder how much a 5-foot fluorescent tube is. And you go into a shop and they say, it's £22. I think, well, hang on, a box of 25 is only 100. So I may as well buy a box of 25 instead of paying for 4 retail. There must be a massive markup on some of this stuff. Scary. So although I'll be retiring in 4 years, it's 67 for me. I'm going to try and keep on all these trade accounts, even if I won't be running a business. Right, we were reading this, we were seeing where the squelch was. It does open. It does just. It opens at 8 millivolts, 8.2 actually. 8.2 millivolts, which is far too tight, but at least it does open. So let's go to the opposite end and see how sensitive the squelch is. So I've put the signal generator to standby at 0.3 of a microvolt. Set the squelch on the radio, signal generator back on. In fact, it works very well. It's 5.8 or 0.58. The RF meter. So I'll start with the S meter. So we've got a 100 microvolt signal on, which is should on a CB radio in the UK be S9, but it isn't. Now on these, we like it to just touch the plus 30, and I mean just. That's where I want it to be, so it's just not on. So on this radio, our S9 is 145 microvolts, so you'd say it was a lazy meter. Doesn't have a meter lamp, so high, low, power switch broken. This gentleman gave me a box of bits once, and I'll look in at his box of bits, see if there's a switch he gave us which we can then give him back for, of course, no fee. Then what else do I want? The potentiometers are absolutely fine, tick that off. The sockets are fine and it doesn't have public address. The mic it's come with it and the speaker both work. The RF meter, when we key it up, put the test set back to transmit, is all 4. Now that is right, but in low power it should be 1, but we can't see what low power is. So I'm going to put 4 because I can't tick it off without seeing low power. So I think the best thing to do, we'll start with deviation, then I can turn the other test set off. So I'll plug into the test set behind me, we'll see what the deviation is. I have to change the glasses because it's a different meter, it's a different thing. Wow, it's absolutely bang on. Good. When we initially read it, it was 2.5 peak on the Marconi test set, and it's 2.5 peak on the Quartz Lot 282A test set. So we'll go back to this test set, see whether this is still telling the truth or whether it's telling us lies. Wallow. It's a bit low now. Right, so that's nice. Something we don't have to twiddle. Mind you, wouldn't mind knowing where the pen is. You can't believe where pens go, can you? Right, let's go through this transmitter, see whether we can get a little bit more. Can I remember what any of the presets do? Of course I can't. So we know our transmitter is up here, so as ever we're looking for not just the peak, but we're looking for the center of the peak. So we're on transmit, it's doing 3.5 watts, and we're going to detune this, which is there, and then we retune it till we get the peak, and then we detune it until we find the absolute peak. So detune it, retune it, detune it, find the center of the peak. Next one the same, detune it, retune it, detune it, there we go. Next one, about there. So we haven't gained much. It's 3.6 watts and it's warmed up, so that would probably be about 3.8 if it was cooled down. So our next one is the one that we've got 2, which the power, that's the power set one. This is the one we're going to do next. Peak. See, that was out, so it's showing about 3.8, which is probably 4 watts now. So this is the one we're going to set the power on. And we've got 3.95 I've set it for at this point. Now the set's warmed up, so it's quite possible it could be over power. Channel 40, 3.9 watts. Channel 1, 4.1 watts. That's okay. It's nice to be within 0.1. So it's 4 watts, 4.1 watts, 3.9 watts. We could go backwards and forwards till the cows come home and get that closer, but it doesn't matter. Right. So that's done that. We can't do low power because we can't get the switch to go into low power. Deviation was 2.2 to 2.5, and it's 2.2 to 2.5, so that was correct. Our transmit current is now 927 milliamps, and before it was 921. So because the interstage SWR is improved, it's drawing a tiny, 6 milliamps more to do that extra 0.4 of a watt. Right, and that's why you can't do a tune-up looking at an ammeter and, right, we'll do it for maximum amps, because it's not going to prove that it's not really going to prove that its interstage coupling is correct. Deviation where? Oh, meter. Yeah, let's have a look at the meter. So I'm going to tread carefully here because I can't test it properly. I think it's the back one. I can't test it properly because we can't do low power. So we're going to key up. We're on channel 20. That should be the preset. I don't even know which way. What I'm going to do, I'm going to turn the power supply down to 12 volts. See whether we can get, because now we're only doing 3.4 watts. We might be able to see this move. No? Oh yes, we can. So that's the minimum you can see. So I'm going to leave it at that. We'll put the power supply back to 13.8. When I key up now, it's showing all 4. Chances are that's the correct position, but the correct position is when you've got 4 bars just in transmit on 4 watts, and when we go to low power, 1 of them lights, not 2. So that's something we'll look at later, but I've set it for now, and I'm sure I'm going to be right. So although it was 4 before and it's 4 now, there's a difference between where they are, because you've only got 4 lights, but there is a difference. Okay, let's look at the receiver. So I'm going to put a hefty signal on of 100 microvolts. We're going to look at our oscilloscope, and the oscilloscope is, where have the mice put it? There. So this is where I'm going to use my RS tool. Where's the detector? It's hidden somewhere. It's going to be somewhere around there, isn't it? Can we see it on our other set? Yes, it's there. Just there. I've got wiring in the way. Now the good thing about that is any screwdriver jockey might not have spotted it. In fact, it was absolutely spot on as it was. So now we're going to be doing, I'll tell you what, we'll do the IF next. I want to see this on the front panel meter and on the cyanide meter and on the oscilloscope at the same time. So I'm looking at all 3. So here we go. We'll go to the cyanide meter for you. So it's quite a saturated signal, and I'm expecting that our IFs are going to be those 2. So back to the 1.5mm tool. So moving that meter further to the left. That's right in the centre. But I have made a gain of had to turn down my signal slightly to compensate. So do that again on this one. That was a bit out. So we'll see whether this is front end or whether it's, I've done that one. It's those two we're left with. So we'll turn the signal generator down. And we'll do those front solely with the cyanide meter. You know, we're gaining something. Let's turn it down a bit further. I've had to change scales, it's so good. So do that one. That was absolutely spot on, but this one wasn't. That's been about 2.5 turns. There we go. That's read off what we've now got for our sensitivity. So I can agree that's about 12. I'm on the wrong scale. I'll tell you what, they don't usually work this well. It's 0.24. You can buy 10 sets, you can buy 100 sets, they're all going to be different. 0.21. It's like one of those York 861s you see 0.19 on, and you think it's 1 in 1,000 that you're just not going to see another one. And 20, it's 0.46. That's really good. So we'll now do the meter, and you see now it's reading S9. I've not altered the meter, but I've got to check it's in the right place. So what we're going to do is to just get the preset so it shows plus 30, and then just back it off the tiniest amount. So there's our plus 30. Just back it off that tiny amount so that it just goes out. Now when we increase the signal, we'll have a plus 30. Because these sets, if you casually set up 100 microvolts for S9, you can find that even with somebody outside the door, it doesn't like the plus 30. So it really has to be on the edge, which it is. So that's S9 done. That's correct at 100 microvolts. So we've just got the squelch to do. Right. So I'm going to put squelch to full. I'll show the attenuator once again. So I want 100 microvolts to be where we open the squelch at full. So squelch is now on full. Signal generator is at 1, 3, 10, 30, 100. So it's not come in. So we want the squelch to come in. It's either that one or that one. I can't remember which. And this is going to be annoying because one of them is deviation, the other is squelch. So then I have to reset deviation if I get it wrong. I think I will take a break and look at my service notes. What I've decided to do, we're going to borrow this switch. I don't like doing things like this because it means I've got to do the job twice, doesn't it? This isn't a scrap set, and we'll borrow the switch. So I haven't got any in stock. So what I'm going to do, we'll put the Duff switch on my radio so that we don't get the wiring wrong. And the bench light fluorescent has finally totally failed. Normally we would order a part, but what it means is this radio would be stuck on this bench until that part comes. And if that's 3 days, that's 3 days we can't do any more jobs. See, we have other benches, but we only do CBs on this bench. Right. So this one, it's easy to remember because it's blue, white, blue. Out of all the scrap chassis we've got, it's always this toggle switch that's snapped off. And I don't think it's the toggle switch's fault. I think it's some heavy-handed people, or they're just they're kicking around in somebody's junk box, aren't they? That's basically what's happened. So it's orange, red, blue. All I need to actually do is to put the red one temporarily on the centre. So I don't know which is low power and which is high, so we're going to find out. So put the radio on, and we will switch picture-in-picture to camera 1, and we can see the meter, especially if I line it up a bit. And we go to the 3 watt scale. We've got more than full scale deflection, so that's the high power. Good. Right. And we're spot on 400 milliwatts. There's not any fee for that, of course. It's one of those things. Right. So low power is nil. Is now 400 milliwatts. We did the squelch, but I've forgotten what the figure was. Let's put the extension speaker on that's mounted on the wall. And let's look at our minimum figure again. It's actually 0.3. So we're going to do the on-the-air test for this, but then tomorrow we're going to switch this set back on, make sure it's still working, and get Mr. Chippy to also look himself for the possibility of dry joints. The fact is that the customer didn't mention there were dry joints, and it's clearly been gone over for dry joints, and I've had to do dry joints, and it wasn't straightforward. It transmitted, didn't receive. I had to do dry joints again. So I think we'll get Mr. Chippy as well. There's no fee for this dry joint things on this particular set with this particular customer, but it's horrible, isn't it, when it's dry joints? So that's 0.3 microvolts, and there we are done. So we're just going to temporarily put the lids on. I'll put a screw in each. That's low power, that's high power. That's power gone off power. So there we have it. 77104. All the instruments have dropped onto there. 100 microvolts. There's 100 microvolts. Great. Power output. Good 4 watts. Deviation. Wallow. Where it should be. Factory original mic. I might run, if we've got a standard replacement mic wired for one of these, I'll do the on-the-air test with that. Then we can compare with the factory original, because it's very rare you see the factory original on these sets, especially still with the factory original plug on the end. So there you have it. 77104 So yeah, it needed a good tune-up. We did have to do the dry joints, and then we had to fit a second-hand switch which we had to fix. Thanks for watching.